Everybody's handwriting is different. Some is more legible than others. This is a sample of my own handwriting, and it's probably on the more illegible side. Is this two words or is it one? What does this word even say? You can imagine how much worse my handwriting was when I was a child. And this is my handwriting when I was a child, so you no longer need to imagine. Teachers often spend 1 day per week marking. What if we can automate this? And this is exactly what Stylus Education have done with their automated marking and feedback service. But how do we provide an AI with written work such that it can then provide the best marks and feedback possible? Well, this is the question I've attempted to answer in my fellowship project. I've been using large language models to transcribe students' written work and then feed it into an automated AI marking and feedback service. In the context of student marking, there are many ways to look at the transcription accuracy. For example, what does it mean to miss a full stop? If you're looking at a student's ability to start and end sentences correctly, it's arguably more important than any other character. Similarly, what if this C is transcribed as an E? Motorbike is still spelled incorrectly, so even if you're assessing a student's ability to spell, it doesn't necessarily matter that you mistranscribed this one character. So it's clear we need to look at a number of different things when looking at the transcription accuracy. The first of which is words. You can simply count how many of the total words are correctly transcribed. You can do the same thing with characters, but you can go more granular. You can look at each individual piece of punctuation as well as each individual capital letter. In terms of the punctuation and capitalization, the way I measure this is by transforming the text such that it only keeps the punctuation in its surrounding context. I do the same thing for the capitalization. Only the capital letters and the surrounding context are kept. Everything else is ignored. In the context of Stylus's marking and feedback service, the only statistically significant correlation between the marking accuracy and the transcription accuracy is with punctuation. As the punctuation accuracy increases, the error in the marking tends to go down, but there's a problem. Punctuation is difficult to transcribe. As you can see from the right here, the punctuation accuracy is far lower than any other accuracy metric. In practice, this is what it looks like. The LLM hallucinates a full stop in between bed and sheep, possibly due to the curly bit at the end of the D. It also hallucinates a full stop between day and Sally when there isn't one. To solve this, I've used prompt engineering. Now, this consists simply of writing new prompts that tell the LLM what to do in order to focus on the deficiencies in the transcription. For example, you may tell it to pay more attention to full stops. Once we create a new prompt, I then transcribe each paper, run the entire transcription pipeline 10 times to account for differences in the transcriptions, and then evaluate the results, calculating statistics across papers and runs for every single metric. And this has resulted in a 22% reduction in punctuation errors. As you can see, it no longer hallucinates these full stops. But this isn't good enough. This question mark after money is mistranscribed as an exclamation mark. The speech marks are missed and a new line is still placed in the wrong place. So this hasn't solved all of our issues. To solve this further, I've used snippeting. Now, this is the practice of splitting each individual page of student work into multiple pieces and sending them into the LLM for transcription separately so it can pay more attention to details. But you have to be careful not to split words in half. To solve this, I've used image processing techniques to only split the pages in between the words, so it only splits on new lines. This has solved a lot of issues with the punctuation. As you can see here, the question mark is now transcribed correctly, the speech mark is transcribed correctly, and the new line is now in the right place. On a paper-by-paper basis, this is where we started. The punctuation accuracy is ranging between 0.5 and 0.9, and it's not super consistent. After prompt engineering, the accuracy is generally increased for most papers, as has the consistency. But when you introduce prompt engineering and snippets, you can see that the punctuation accuracy is vastly improved and it's much more consistent across runs. Now, what does this mean in the context of the overall marking? Well, this gives us an overall 52% reduction in punctuation errors. And this translates into up to a 46% reduction in the errors in the marking. This has already been applied on 500 pages of real student work from multiple UK schools. But there's a wider impact. The cost of an LLM call is always much less than the cost of a person's time. And any situation where you have poor handwriting, but where the details are vitally important, an example here is with doctor's handwriting, which is famously bad, but full of important details, this LLM-powered transcription will come in useful. I'm Jake Amey, and thank you for listening.